Cut that off, but I would like to introduce Dr. Anthony Strawa, the SSV Chief Scientist. He has over 15 years of experience as a NASA atmospheric scientist with focus on global problems of stratospheric ozone depletion, climate, and air pollution. He has over 50 peer-reviewed publications and over 900 citations. He reports today on the development within and without SSV's Air Quality Program, and I think gets into some transportation issues as well. And there you are.
All right. Thanks a lot, Dennis. Go ahead and share my screen here and we'll get going.
Okay.
Okay. So as Dennis mentioned, I'm Anthony Strawa, Chief Scientist at SSV, and I'll be talking about the Air Quality and Mobility Program that we have started. I can get this to advance. There we go. So we're kind of switching gears. We talked about electrification, we talked about water, and then we talked a little bit about the air district's efforts in air pollution. So I'll go into just a little bit more detail over there. The kinds of things that we're most interested in are called the criteria pollutants, the EPA criteria pollutants. They're ozone, carbon monoxide, nitrogen dioxide, and sulfuric dioxide. And they are associated, the reason we're interested in them is because they are associated with many illnesses, including asthma and heart problems and things like that. And also another criteria pollutant is particulate matter that's in the air, little particles, dust particles and smoke particles that are in the air. They can be also linked to respiratory diseases. And to give you an idea, the picture on the bottom right there shows you what the PM 2.5 and PM 10 really refer to. So PM 2.5 are particles that are smaller in diameter than 2.5 microns. You can see that human hair is about 50 to 70 microns. So PM 10, there'd be 5 to 7 particles in that diameter. And in each PM 10, there's 4 PM 2.5. PM actually stands for particulate mass. And that's because that's what the federal criteria is written for. And the reason these things are important is because particularly PM 2.5 can get down into your lungs, into the alveoli, and disrupt the process by which air oxygen is converted into the bloodstream. PM comes from point sources such as industrial processes and vehicles. So the motivation, one of the motivations for the community air monitoring projects that we're involved with is the fact that, as you can see here, the South Bay area, there's a bunch of low-cost sensors over here, and hundreds of them. But the federal reference methods there are only 2 federal reference measurement sites in this area, one at Redwood City and then one in San Jose. And so you don't get a feel for all the different variations. Everybody talks about microclimates in the Bay Area because of all the terrain and stuff that we have. And that's the same thing goes for air quality. And additionally, there are point sources at various places. For instance, the cement plant outside Cupertino that causes a lot of particulate matter locally. And so we think it's important to have local measurements of these air sources. Now, this picture was taken during the fire season in 2020. You can see that numbers are quite high. In general, the air quality is is good to moderate. If you think back to the air quality index that was in the little video that the Air District made, that Dennis showed you a little while ago. The other thing is that the average numbers of unhealthy days in the Bay Area is up. And you can see this breaks California down into regions. The red is in 2000 to 2015 and 2016 to 2020 in black. And you can see in our area, the Bay Area, there's been a tremendous increase in bad air quality days. I would think that at least half of that is due to the increase in wildfires. But at any rate, it's important to get down and get really local measurements so that we can identify what's going on. And that is indeed one of the trends, to get localized data and make that data more accessible to citizens and communities. And that's one of the core elements of the SSV program. Pardon me. So one of the projects that we did kind of first up with our air quality and mobility program was called Smart TA. It was in the area of East Palo Alto, and motivated by the fact that East Palo Alto residents had higher incidences of asthma than the general population in the county. And so residents were concerned about that. They were concerned that perhaps all the pass-through traffic coming from the Dumbarton Bridge to Highway 101 might be affecting their air quality. And so we had a couple of sensors, 3 sensor suites. It included gas phase measurements, like I mentioned, and particulate phase measurements at 3 locations on either side of University Avenue, between the Dumbarton and Highway 101. And made measurements for several months over in that area. And we found, first of all, you can see in the top part over here that the red line is the air quality based on particulate matter, and it's this is an air quality index. And the blue line is a measurement of congestion that we got from what's called floating car data in the area. So when your app that gives you directions and things like that, whether you use Google or Waze or one of the other ones, they take that data, they anonymize it, and they sell it to third parties. And so the third parties then do some algorithms that convert that to, traffic wait time and congestion and things like that. And so that's what we're comparing it with. And you can see that there's this bottom is time, that there's a correlation with these 2 humps that correspond to morning and evening rush hours, and they're correlated. So air quality is worse during rush hours, but in the lower charts, you see air quality index, and anything below the green line is considered good air quality, and anything below the yellow line is considered moderate air quality. So even in the worst days of the 4 months that we measured, which was in the summer and early fall, the air quality in the area where we were measuring in East Palo Alto was never unhealthy. These measurements are hourly averaged, and there may have been spikes that go up, but only for brief periods of time in order to keep these averages down in the good to healthy areas. So there's a correlation between traffic, as you might expect, but the air quality is still good. So the underlying cause for the increase in sicknesses that you see in East Palo Alto, we can't really tell from these measurements. I think we need to have a much more sophisticated experiments in order to get to the bottom of that. So that was kind of the first project that we worked on. Here's another project that has just been completed called Intelligent Transit Signal Priority. And SSV teamed with a company called Light to test what would happen to traffic if you prioritize buses. So for instance, if a bus is coming to a traffic light, instead of that light turning red at that point, you gave you allowed the light to stay green until that bus went through. What effect would that have on traffic? What effect would that have on pollution? And so that was very successful. You can see a little picture over here shows Lyft controlling the sensors in the buses and emergency vehicles being prioritized. It demonstrated a significant improvement in travel times. We did not make air quality measurements during this time, but one air quality would improve at the same time. And it reduced northbound intersection delays by 45%. And so these charts bear that out. The baseline, northbound baseline and northbound with our controllers was significantly less runtime, dwell time, and intersection delay when the engines are just running at idle. Okay. So also based on our experience working with the Smart TA project, SSV Labs developed this backpack. You can see a picture of the backpack over here, draped on someone's backpack, and that's where we get the name from. And the backpack measures particulate matter as well as certain gas phase measurements. Right now, we're measuring CO2. And we did a pilot project with this device with students at East Palo Alto and Dublin High School, and tested the sensors for 3 months and got evaluations. And associated with this backpack, a mobile app was developed that allowed you to look at real-time data on your phone. And also a web application was designed to allow you to go in and take a look at the air quality as a function of, measurements every second or so, as you walked around from in your neighborhood with the backpack, or if you're walking around from different rooms in the house. And so we felt this was particularly important to highlight the fact, as we heard Sean talk about earlier, the fact that, if you're cooking on a gas stove, you're putting a lot of pollutants into the air. And so, or if someone in the house is smoking, they're putting a lot of pollutants in the air. And that could be a very damaging thing. But this project gave the students some chance to get some hands-on experience working with these devices, to take them around to their local neighborhood, look for different changes that they occurred, and also to put them into rooms of the house to get an idea of how the air pollution changed based on the room and the activities that were going on there. I can tell you from previous research that not only the cooking process produces particulate matter, but also just burning the gas, even if you weren't cooking anything, puts particulates and methane and CO into the air. Another big source of pollution indoors are carpets. So as you walk along the carpet, your foot scrapes up particles that float all over the place. So those are two big sources of indoor air pollution. Okay, and we're just kicking off our Youth Air Quality Advocates program. It's a program that's funded by the California Air Resources Board. It's a 2-year project, and we're targeting high schools in San Jose East Side Union High School District. The program is designed to provide community advocacy, advanced environmental justice initiatives, and engage students in activities geared towards these things and civic science, citizen science, and civic action. The program will train teachers over the summertime so that they can engage students in hands-on curriculum that will teach them about air pollution and guide them to understanding how to understand all these numbers that they're looking at. If you've had a chance to go visit the Air Now site or the Purple Air site, you see all these air quality index numbers flying around. So what does that stuff really mean? What goes into defining those numbers? As I mentioned, the criteria for particulate matter is mass, but these devices do not measure mass. They measure scattering from the particles. And so how reliable are those kinds of measurements really? And hopefully the students will present their findings to their communities, to houses of worship, civic meetings, and perhaps to local policymakers. We've got a nice quote here from Mayor Liccardo about the challenges that people have with air quality and climate change. Okay, finally, there are three elements to our air quality and mobility vision. First and foremost is community education and involvement. We also like to use low-cost sensor technology to make our communities healthier and more sustainable. These low-cost sensors have proven useful in educating people about what's going on and providing more local measurements so they can really understand what's going on in their community and not in the whole area as at large, and to provide student education and empowerment. So those are our goals. We are active in doing these kinds of projects throughout the Silicon Valley area, and we'd love to have you join us. Thank you very much.
Thank you, Tony. I, yeah, again, see that the comprehensiveness of your presentation was such that I don't have any available questions for you.
All righty.
But we definitely look forward to further developments along all the lines that you mentioned, and hopefully we won't have a lot of very bad air events like the orange air days with which to draw some lines.
Okay,
there is one question actually that did pop up. Well, it's a bit of a general question. How do you anticipate the solution path will be? I'm just saying. Yeah. So I'm not sure.
Yeah.
How to?
Maybe whoever posted that could provide a little explanation, but I would assume you're talking about how we clean the air up.
Okay. Yeah, I would think that would be the case.
And so, you want to get first of all the vehicles off the road if possible, or at least not off the road, but not burning gas, not burning fossil fuels. And the same thing goes for generation of electricity. You want that to be by renewable sources and not by fossil fuels. In general, there's tech available for point sources. There is tech available for point sources. I think getting away from burning fossil fuels is a must, because it not only contributes to air pollution, it also contributes to climate change, and the two are linked, interchangeable. Um, let's see. The other thing is by policy. So for instance, that mobility exercise that we did in East Palo Alto, where we prioritized buses so that they were not sitting idly on at red lights, also apply to vehicles. So the data also shows that just normal vehicles spent less time idling and therefore less time polluting. So there can be policies encouraging bike lanes, encouraging rapid transit, those kinds of things are all ways to get to the solution.
Yeah, and you
Okay.
mentioned, for instance, I thought it was pretty pointed. You mentioned just even in terms of the in Cupertino, that there's some kind of mining operations there that
The cement
kind of are
plant.
known offenders,
Yeah.
and obviously that's a point source. But there isn't actually there isn't an easy tech for that particular point source. But if it is a harm to the air of the area around Cupertino and beyond, it's something that should be looked at.